嗨，大家好，欢迎回到 JVM 狂欢嘉年华的议程轨。那这个议程轨呢，基本上都是在跟大家分享 JVM 相关的主题，包括 Java、Kotlin、Scala 或是 Groovy 或者是Clojure 这一些跟 JVM 有关的一些语言以及相关的技术哦。那我是这个议程轨的主持人，我是盛佑。那目前在 JetBrains 担任技术传教士。那我们这一个议程呢，很高兴可以邀请到彦斌。那彦斌大家都知道，他是我们这个 Android 台北的这个读书会的主办人之一哦。那目前他也在那个 Pitt College 这间公司担任 Android 工程师。那 Pitt College 呢，它是一个可以帮你做这个拼贴照片的一个手机 App 哦。那中文翻译叫拼贴去哦。那我们先请彦斌跟大家打个招呼。
嗨嗨，我是彦斌。首先我要证明一下，我们的名字叫
对不起，
Pitt College，Pitt
Pitt
College，
College，
对
Pitt College。
对，这个
OK，sorry，这个发音有问题。
念错，那没关系。对，这也趁机跟大家宣传一下我们的正确发音。然后这次演讲会很任性用英文讲，我用中文跟用英文里面的内容，其实我不会差太多，可能会流畅度会稍微有点差一点。对，那就请大家稍微忍耐一下我任性，但如果到时候要发问，也是可以用中文发问是 OK 的。嗯，
好，没有问题哦。我觉得大家都应该像彦斌一样勇于挑战哦，因为我们也要把自己的这个发表的方式迈向国际化哦。所以我们这一场议程就会有彦斌用英文发表。好，那我们现在就请彦斌跟我们分享这个议程。这个议程是 Android Reactive Architecture in Kotlin。
Welcome to this talk. And my topic today is Android Reactive Architecture in Kotlin. And my name is Yan Bin. And something about me, I'm an Android developer working at Picard. And you can follow me on my Twitter, Medium, and GitHub. Here's my links. And this talk won't cover these topics in detail. First one, I assume you already know how to write Android app, and you know what is RxJava, or you know any other Rx extension libraries like RxSwift and RxJS. And you know how to use basic operators like mat, filter, or reduce. And finally, MVVM architecture pattern. I assume you already know all of that. For the app I'm going to introduce today is a responsive sticky note. As you can see on the screen, there's many sticky notes on the screen, and you can modify them, create them, and delete them. And this app is cooperative. So it means other people can also do the same action with you and collaborate with you on the same board, which means all this data is on the cloud. You can check it out, the detailed code on this repo link. Next is a refresher about reactive programming. Reactive programming is a programming with a synchronous data stream. On the left-hand side, there's an observable, and on the right-hand side is an observer. For the observable, is response for emitting events. And about observer, once the observer is subscribed to an observable, it can receiving the events from observable. And there's a different ways of handling observable stream. On the left-hand side, an observable can send events to different observables. We call this multicast. And on the right-hand side, many observables can emit streams and merge them together to a single observable. We call this merge. And we'll see example later. And this is an architecture overview for this app. This is a standard MVVM architecture. For the view layer, I'm using Jetpack Compose. And the main responsibility for this layer is gesture input and draw all the UI components. And for the view model layer, it is responsible for all business logic. And for the model layer, it's responsible for all the data, creation, modification, or delete. And I use called FireStore here. One of the most important features in this app is you can drag sticky note around. And I'll start with 2 layers only. Model layer will be introduced later. So here, view model layer is responsible for business logic and data, and view is still the same. So on the screen, imagine there's a finger input, and it will produce the position delta from the finger input, and we'll know what the sticky node it is touching. So we'll have a sticky node ID. And once the information sent to view model, the view model can produce the new node and then send the new node to a list. So for the list, it should be drawn on the screen. How does the view know the list? It is done by subscription. So here, view has the observer and view model has the observable. View's observer is subscribing to observable so that you can receive the latest string of list of nodes. And here is a little example. Initially, we have a list node position, which ID is A and position is 50-50. After view subscribing to it, you can get the latest node list, and it will draw the latest node at position 50 and 50. And then there might be a gesture input from user, which will produce a delta x is 10, y is 10. And send this latest information to a view model. The view model produces a new node, which has a position 60 and 60. And then send the latest node to a node list. Finally, by the observable chain, you can draw the latest position on the screen, which is 60 and 60. And the next is the implementation part for now. There's an editor view model, and the first one is node. It is a variable that can be subscribed by the view layer. And there's a one public function update node position, which can receive position delta. And for the views implementation, there's an editor screen. Editor screen can have a dependency for the view model and can manipulate this view model. As you can see in 922 and 923. 922 has a subscribe as state, which subscribe the observable from view model. And in 923, view model can pass this update node position as lambda to for view. And for the for views implementation, you can see the implementation detail in my report. Okay, then that's all views implementation. Let's see for the view models implementation. There's a 2 errors between view model and view. One is ID and position delta. This is the input, and output is the observable. So how can we implement this? You can implement this by a subject. The subject is both the observer and the observable. As you can see in this image, an observer can subscribe events from a subject, but the observer can also subscribe event from an observable. What's the difference? The difference between observable and subject is that subject can receive events from outside world, but observable cannot receive any events. So in our case, the view model can receive the events from the view layer by a subject and then transform it to an observable, and then this observable can be subscribed by the view model, by the view. So you can see in this code. In 916, there's a all node subject, and in 918, all node subject can transform a subject to an observable by using this function. It's called hide. It's super easy. And how does the subject receive events? You can see 928. All node subject can receive event by this easy function. It's called onNext. Once we call onNext, the all node subject can receive this event and emit this event to somewhere else. And for the update node position, when the view calls update node position, we will find the current node from our cache, which is a hash map by its ID, and we'll copy the current node and its position delta, which will produce the new node, and then set it to node list, which will then trigger our subject's update. And that's for our view layers and view models implementation. What does it look like when we add another layer, which is reactive model? Why I call this reactive model a non-model is because that a reactive model can express the idea of reactiveness. A reactive model should return all this data in a reactive way. So everything comes from reactive model layer should be observable. After we add another layer, which is the reactive model layer, the data flow diagram is changed. The view model now is responsible for business logic, and the reactive model now is responsible for data. The data is in the node list. So the node list is the observable, and this observable will send through view model and then subscribe it by the view. And for the gesture input from the view model will receive the position delta. It is the same as before, but the difference is it will send a new node to the reactive model. Okay, let's see some example. Here we have a view, which has already have a node. Its position is 60 and 60, and all the data is coming from reactive model. And then there's the input one gesture. The gesture input is x is 10, y is 10, and then it will send to a view model. So the view model will produce a new node, which position is 70 and 70. Then the reactive model will receive the latest node to produce the new node list. And the new node list will contain the data like this. And finally, this new node list will send through view model to the view and generate the final output, which will draw the position into 70 and 70. And for the implementation of this part, since the original implementation, the view model is responsible for business logic and data. And now the data is dedicated to the reactive model. So the new implementation is super easy. We just move the hash map and the subject to the reactive model. And yeah, the implementation looks like this. It just moves the subject and the hash map from view model, and it's just stored in a memory. So I call this in-memory node repository. And what about view model? Since all the data is copied to a reactive model, so we don't have hash map anymore. So we cannot get the corresponding node from its ID and then produce a new node. So now we need to switch to another approach. And you can see this observable coming from reactive model, which is all nodes. And maybe we can use this all node to produce another subject, or then use this subject to produce new nodes, maybe. Yeah, of course, we can use another subject and we can get data from subject directly. But with this approach, it's not very clean and not very elegant because the subject can be changed by anyone. So this is kind of dangerous if we don't have another solution. We just not think about this solution. So there's another solution. The solution is we can use merge observable. With merge observable, we can produce two observable here. The first one is the position delta and ID, and the second one is all nodes, this observable. We can merge these two observable to produce new node. Since all nodes observable has the latest nodes, and we can get the node from the nodes from its ID to produce new node. And yeah, but there's a different operators in merge observables. We need to choose the correct one. So for the correct one is with latest from. We can use this operator. So what does this operator do? This operator is only emit the latest value once. So whenever a position delta update, we can only get one value from the all nodes observable by using the operator with latest from and get a new node. But if we don't use it with latest from, we use something like combine latest, this operator, it will produce 2 or 3 or more new nodes, which will introduce bug to this app, which we won't want to see. Then this is the implementation of the merge observable. In 9.22, there's an operator with latest from, and the with latest from, first parameter receive one single observable, which is all nodes. And in 9.21, the observable just created by position delta. So we merge these two observables to produce the new nodes, and then in 9.28, it will put this new node. So now we have a reactive model there, which is the response for data. But this is only an in-memory storage. Our requirement is to build a collaborative sticky node. And so we need a centralizing data storage, right? So for the storage, I use called FireStore to store all this data. Okay, then let's just swap the internal storage for FireStore. And I will skip the implementation because this is very straightforward. And if you are curious, you can check my GitHub repo. And after we swap the implementation to Firebase Store and build this app, it will look like this. This little circle is my finger. As you can see, my finger dragged along, but the sticky node not act as I expected. And after I release the finger, the sticky node is moving. This just look weird, right? What happened? Let's show you what the root cause of this bug. There are two different colors of circles on the screen. For the red one, we can think about it is execute on the main thread. And for the orange one, it is execute on the background thread. So for the orange one, for the upper one is the event that update the new node. And for the bottom one, it represents the node list coming from Firebase. And let's assume all these two events will total takes 200 milliseconds. And for the red one, the gesture input might send every event for every 30 milliseconds. So the frequency is not the same. There are just too many events coming from the view, and the Firebase cannot keep up and will cause this bug. There's a term in reactive programming to call it, and this term is backpressure. So the backpressure is describing when there's an observable and observable is sending many events, and the consumer just cannot consume all the events. And we have a solution for it. In general, we call this operator is debounce. As you can see on the screen, after we do the debounce operation, the event will reduce almost 1/4 of it. So it will reduce the amount of event that the consumer can consume it. So now we have a solution. Whenever there's an event coming from view model, we will go through a debounce operation and then send this event to Firebase. And after maybe about 100 milliseconds later, the view will get all this result to display. But imagine you are a user. When we use this app, you are dragging the sticky note around, but it won't show the latest result until 200 milliseconds later. That's just not a good user experience, right? So we will need another signal that is only for local, which is you can see on the bottom side. So we need to share these signals to two different observables. And this action we call multicast. A multicast means that an observable can share events to two or more observables. So this is the implementation of multicast. Again, we use subject. When there's a new event coming from view model, we just update the event through this subject. And we might have 2 or 3 different observers for one subject, but in this case, we only have 2 observers. One observer subscribed into the subject is to upload the latest event to a Firebase, and it will go through debounce. And the second one, subscribing to the subject, is only for local to display the latest result, and the user experience will be better. And since our interface of the reactive model is a single list of nodes, so we need to somehow find a way to combine the result from local and from Firebase. So here again, we use merge observable. The observable from local is for better user experience, and the observable from Firebase is for the operation that coming from other users, since we are using a centralized data storage, and this is a cooperative sticky note. So we all need to get an event from someone else. And the operator we are using here is combined latest. What's the difference between combined latest and with latest from? The difference is that the combined latest will receive every event update, but with latest from is only receive one event from the data observable. So in this case, we use combined latest here. It's better suited in this situation. In the end of this talk, I want to talk about performance issue. If we have a 10K sticky node on the board and still using the same interface, that which is an observable of list of node, whenever there's an event coming from Firebase, we all need to convert 10K sticky node object at once. So that might cause a memory overhead. So we might need to change our structure to solve this problem. And the second one is replace observable string. As I mentioned before, there's a technique called multicast. A multicast can subscribe the same observable by different observer, but the subscription might cause the observable to replay the same function again and again. And it will cause CPU overhead and memory overhead. And let's recap. I have talked about the responsibility of different layers, which is view layer, view model layer, and reactive model layer. And in reactive programming, it's pretty common to use multicast and merge observable to solve problems. And also, I talk about backpressure problem. This happens when the observable is sending too many events that observer cannot keep up. If you have any question in this talk, you're very welcome to open new issue here, my GitHub repo about reactive sticky note. And that's it. Thanks for watching.
好，那我们谢谢彦斌这场这个非常精彩的分享哦。那因为我们在直播上面可能会有些时间延迟哦，所以大家可能需要一点时间才会把问题显示在 Slido 上面。那不过我想彦斌分享这个 Reactive 这个 Programming 的这个概念，其实是在现在不管是在JVM 的这个生态圈，或是在 Kotlin 或是 Android 这一方面开发上，其实都还算是一个蛮热门的一个主题吧，对不对，彦斌？
对，就我们公司其实已经用了3年多左右了，然后一直有蛮多的线上的讨论在讨论这个相关议题，然后最近就是 Coroutine 那边有开发一个 library， 应该算是 extension 嘛，就是 Flow， 它其实用 Reactive Programming 方式去设计，所以其实对吧，蛮多不同的设计方或者是不同 library 都雨后春笋冒出来，就觉得对吧，是蛮值得讨论，看大家对这边有什么看法、想法，或者是大家有踩过什么的，可以欢迎找我讨论。
对，就是我想因为彦斌现在其实也有在我们大会的那个 Gather Town， 我们 JVM 狂欢嘉年华的摊位上面哦，所以等一下万一时间来不及的话，大家还可以移驾到我们摊位上去继续跟他做一些更多的互动。那我们现在您看到在 Slido 上面已经有一个问题哦，就是他问到这个 RxJava 跟 Rx Kotlin 的差异哦，那只是在语法上的不同吗？还是什么？这部分不知道彦斌有没有什么经验？
好，其实大部分的东西都会写在 RxJava 上，那些 observable 啊、single 啊，还有 completable 这些都在 RxJava。那 Rx Kotlin 其实比较算是它的语法堂，它有加一些 extension， 可以让你更容易去做呼叫，因为 RxJava 就是 build on Java 上面嘛，它有些东西因为有 Java 限制，没办法让你能够那么轻松去操作某些 API。所以是它会显得比较啰嗦一点。那 Rx Kotlin 它会比较简便轻便。
这样听起来好像就是好像蛮多library 做法都是这样嘛，就是它可能先写了一个 Java 版本，然后 Kotlin 的部分就是用一些 extension 或是加了很多语法堂，让它写得更像 Kotlin 一点这样。
对，但我不知道未来有没有人会想要直接开发 pure Kotlin 的版本，就是可能是一种对方向。
对，也蛮好奇的。对，因为我觉得像 Rx 开头的这种 library， 其实这几年也是蛮多。我觉得也不只是 JVM 生态系啦，就是所有的程式语言好像都有类似的这种 pattern 出现嘛，对不对？对，也是蛮期待的。
它有很多不同的 implementation， JS 啊、Swift、C# 好像都有。
对，我也是看到像前端好像也蛮多JavaScript 相关的一些实作，他们也是有做这种 Rx pattern。对。好，那因为时间的关系哦，那我想假如大家有更多问题的话，可以直接到我们大会的 Gather Town 跟讲者互动。那彦斌现在他的虚拟小人物已经在那个 Gather Town 我们 JVM 的摊位上面出现了。那我们 JVM 的摊位呢，在大会的这个摊位地图1就是 Booth 1那边的右上角你会看到有一个 JVM 一个黑色底的那个看棒，然后上面有一个 JVM 的这个字样呢，就是我们 JVM 狂欢嘉年华的摊位。那我们除了这个彦斌在现场之外呢，我们早上的几位讲者现在也都在 那个摊位上，而且我看到我们现在摊位人满为患哦，所以只要大家有兴趣欢迎到我们摊位上继续跟我们的讲者做交流。好，那我们这一场就感谢彦斌跟我们的分享。好，那我们就谢谢他，然后我们到摊位上继续做互动了，谢谢。
好，谢谢大家。